Welcome to our final presentation of the Selection Criteria of Materials course. Each team member is presenting a part of this project. My name is Samuli Kortelainen, and I will briefly tell you the topic we chose and reasons for why. So, we chose to examine an electric scooter for a number of reasons. First of all, it's a great fit in this course. We are combining aspects of industrial design and engineering science, and every materials decision is reasoned through green technology. Secondly, during the recent years, electric scooters has become a very popular transportation method for short distance traveling. And as they grow in popularity, the sustainable manufacturing, the durability, and the user experience is only becoming more important. From a sustainability point of view, scooters are a reasonable supplement to other forms of traveling, as they are replacing vehicles as taxis and private cars. They are as well being a sensible addition to public transportation. Scooters are classified as consumer products, which gives them a strong dimension of industrial design. And in industrial design, we have to understand the user and brand values as aesthetics, for example. Scooters are also a product of engineering, so technical aspects are very much required as well. Take the next slide, please. So we went through different parts of the scooter, and we chose to study deeper at two separate parts. Number one, the frame and the handle, which is also referred as the grip in the presentation. The frame is concentrating deeper on engineering aspects, and the grip is concentrating on industrial design.
So, as Samuli has just mentioned, we will focus on two aspects of the scooter, the frame and the handle. So in order to begin with the systematic selection process of materials, we have to first consider the different requirements profile for each of those components. Basically, the requirements for both of those components depend on the functionality of the product, of the component itself, the different environmental and working conditions it's in, the different production methods, the costs, and users. Since we come from an IDE background, it's important to also consider what the users want or feel when using the product. For both of the components, we have considered different aspects as the requirement, the reason why we have chosen that requirement, and what kind of comparable parameters may be used in order to compare different sorts of materials. Starting off with the frame, very important aspects are the loading capacity. It's going to be different dynamic loading, maximum 120 kilos, for example. The different corrosion resistance, as it's in different weather conditions, it's going to possibly be located outside. The weight needs to be also optimized in order to increase battery life. So the density, for example, there would be the parameter to be considered. Manufacturability and sustainability aspects are also considered to be very important. The different surface treatments, this may be related especially with the brand values, as the component needs to have certain colors or stickers may be attached to it. The cost needs to be competitive, and the impact resistance is also considered to be important, as it would be located outside and suffer from different kind of impacts. Now moving on to the handle, the requirements are slightly different since it's a different component or part of the scooter. So for example, the wear resistance is going to be something very important to consider, as it is used by different people with different hand pressures may be applied to the component. So the hardness or the impact resistance needs to be considered there. The different weather resistance or water resistance, it's going to be located outside in different weather conditions, such as sunlight, snow, ice, and rain, for example. The environmental and sustainability aspects, it's important to consider a product that may be recycled, as we will see later also different aspects of manufacturability, weight, and costs might need to be included, since the product may be used several times by different users and may need disposal costs because it may suffer from wear resistance. And the reliability and ergonomic aspects also need to be considered, and these are what we will talk about now in the next section related with the selection strategy.
So our selection strategy were made on focusing on three things that we thought are most important to any products: durability, sustainability, and brand values. We were analyzing about the impacts a scooter were getting hit by while riding, wears after a rider, and different weather conditions. We were thinking to use the material that was easy to recyclable. We also thought about the looks and the comfortability of a scooter. To talk about the durability, as we all know, the scooter is mostly used outside for commuting purpose. There can be different weather conditions, like extreme cold in Finland, hotness in summer. For this purpose, we're trying to select those materials which can tolerate these conditions and function properly in those severe conditions. For this, we focused on material which have high resistance to the corrosive environment, as well as strong load-bearing capacity. As we all know, users of these scooters are going to be of different masses. So talk about the sustainability. Another strategy to select the materials. We chose the material that were made of biomaterials or recycled materials, that it contains some of the biomaterials. Recyclability of metals were also considered, as this will help to reduce new raw materials. At least like if some percentage of the old material are recyclable, and those can be reused for the next product. So the next slide is, so the brand value is other strategy. As we all know that scooter need to be good looking as well as comfortable. Some materials need surface finishing touch, some don't. And surface finishing for some material can increase the price for the whole products, resulting in increase in price for consumers. The products always need to have a good value for the price. So selection of the right material is important. The brand connects the people or users, so brand value is important. So now my colleague Hai will talk more about
the list of possible materials of frames that comply with the defined requirements profile was made. One of the key aspects that have been taken into consideration is high durability, since these scooters will be used in public transportation and therefore will suffer from constant impacts and various loading cases. Another factor considered is the material needs to have a certain degree of manufacturability in accordance with the geometry of the frame that most likely will need to be a welded structure. For reference, components used in similar applications and industries such as bicycles were studied to get a general idea of commonly used materials in this field. Steel and steel alloy has high durability, good corrosion resistance, good manufacturability, and cost efficient. Some of them can be used in similar applications like bicycle frames. Reinforced polymer is durable polymer with low density. Aluminum alloy has low density, good corrosion resistance, good formability, and weldability, and can be used in some applications like bicycle frames, where some of them is very harder to weld. Titanium alloy is lightweight, has high corrosion resistance, and good fatigue strength properties, and performs well at low temperatures. Stainless steel has high durability, high corrosion resistance, good manufacturability, and good fatigue and strength properties. As for initial possible handle material selection is based on mechanical durability, impact resistance, manufacturing methods, sustainability, and usage also in low temperatures. Handle materials should be soft materials with expectancy to feel comfortable against the palms. Rubber and plastics are chosen on the basis that they are widely used in handles in various applications and sport industries. Thermoplastic elastomers TPE can be manufactured of recycled material, has great damping properties, great properties in low temperatures, and great resistance to wear. Among TPE is flexible in low temperatures, using temperature from the range -40 centigrade to 120 centigrade. Another material group, natural rubber, is tensile material that is easy to work, has good wear and tear resistance, good elastic recovery property, and performs well in low temperatures. Natural rubber has a very wide scale of hardness, a very firm and naturally self-reinforced material, and good compression set. Silicone rubber has low tensile strength, poor wear and tear properties, but has excellent low temperature flexibility. Silicone rubber is a material that of choice in industry when retention of inertial shape and mechanical strength are desired and heavy thermal strength. PVC is ideally suitable to be recycled with good UV light resistance. Manufacturing properties are analyzed. PVC can both be manufactured to be a very soft material and a hard and stiff material.
Yes, hello, this is Kari. I'm covering the material property comparison. So for the frame, the weight density is important part, and as the frame has the dynamic loading, particular strength fatigue is important element of this, and also impact resistant hardness is because the frame is subject for external impacts. Corrosion resistant is important. And in manufacturability, weldability, and formability are both important. Cost needs to be considered as well as the sustainability, where the energy consumption and the recyclability is very important. For the handle, the strength properties, hardness is important because the handle is in direct interaction with the human hand, so the touch and feel is important. Durability, tear strength, as well as manufacturability are also very important. We had the high focus on the sustainability of the scooter, and the recycling opportunities for the handle materials were limited, so we put high focus on the bio-based material content. Next slide. So after the initial evaluation of the materials, we narrowed down the options to three materials for the frame: one aluminum alloy, one stainless steel, and one alloyed steel options. And for the handle, we were selecting four most viable options for the final selection process. So we can take the next one. So here we have this comparison of the mechanical properties of these final materials for the frame and average cost of the material. Very important for the cost item is that we also need to consider that, for example, for aluminum, we would need more material to achieve the same strength properties than compared to steel options. And as for the handle, we have all the different strength measurements here, and we also have the biomaterial content and the recyclability information. But as already said, the biomaterial content of this case was very important for the sustainable aspect for the handle.
Okay, and to summarize what Kari just said and told about the material property comparisons, some materials were left out from the final comparison because of various reasons, whether it was the cost of the material or just not fitting our brand values, or there wasn't really a strong case for sustainability. But for frame materials, we chose three most potential materials based on the compared values Kari presented, and for the handle we chose four materials to be the most potential. And after comparing these materials more carefully, we came to a conclusion that for frame, alloy steel IC4130 would be our preferred choice for the following reasons. Recyclability of steel is excellent. Generally speaking, the cost of the material or the cost performance ratio for the material was really great compared to stainless steel and aluminium, and also alloy steel is suitable for different kind of coatings and paints. Like if we want to change the appearance of our scooter, it would then be really possible with this material. And for the handle material, we chose triplex SC TPS material. As Kari mentioned already, it has a really high bio-based content, which fits well to our sustainability or our emphasis on sustainability. It comes with suitable softness, so it feels nice against your palm. Mechanical properties we're comparing well with other materials we have here, and also it's suitable for injection molding, which gives us certain freedom in terms of product design. And material selection process doesn't really end when the material is selected for the first time. So when we would manufacture these scooters and really start renting them, we would do some sort of monitoring and gather feedback from the consumers. Like there is a risk that we have maybe underspecified something. Scooters might start breaking when used, so we would then need to revisit our material selection and maybe choose something else, or vice versa. There's a possibility of overspecifying a material, so we might have chosen too expensive materials, for instance, and there's a possibility to reduce the cost of the scooter by changing the material to something else. And also, since materials are always developing, material industries are coming up with new materials all the time, so it's important to keep yourself up to date what happens in these industries, since new material possibilities might come available in the future. This was our presentation. Thank you for listening. At the end, I would like to thank the whole team for great work.